So I think for me, I was excited, and I specifically asked for this opportunity to kind of sit down with you, Jay, and kind of have this conversation of, I called him a unicorn earlier, because so many times we see amazing innovation, science going on in our national labs, but it's not necessarily in their DNA to go actually co-found or found these companies, let alone over a dozen. And so I wanted to sort of just ask you to share with the group what you find, what challenges you've seen in the labs to do this, and what advice maybe you would give to the next generation.
Yeah, so first, I do it because I love to do it. I want to see the basic science that we do in the laboratory get out to benefit people. And it started over 2 decades ago. We were engineering a microbe to produce an anti-malarial drug called artemisinin. And it was just very clear that the pharma companies out there weren't interested and motivated in solving malaria. And so we took this basic concept, founded a company, and that company ended up scaling up the yeast that produced this anti-malarial drug and then licensing it out to a company that produced it, and then started working on biofuels, flavors and fragrances, and a variety of other molecules. And I kind of caught this disease that is such a good disease of wanting to start a company and companies to commercialize things. And it's just, in my view, small companies are some of the best ways to commercialize deep science. And part of it is because the companies are invested in it, in doing it. And often if it goes to a large company, they might do it very well, or they might have a change and decide not to commercialize it at all. So it's just, and part of it also is paying back the taxpayer, because the taxpayer funds the science that we do, and I'd like to put something back in their hands that comes from that basic science. I'll also say that, for all the successes, there are many more failures. And you have to get used to failing. And you have to accept it as part of inventing, as part of commercializing. There are going to be failures. And if there aren't failures, then you're not pushing the boundary hard enough. The other thing I've learned is almost always the science and technology succeeds. What doesn't succeed is the business case often. And you might have a technology that is fantastic, but if it isn't needed, then nobody's going to buy it. The company's not going to succeed. And so it's kind of finding the sweet spot in there of having a technology that is really fun to commercialize, that you're really enthusiastic about, but also delivering something that's going to help people in some way. And we're in a capitalistic society. They have to pay for it in some way.
I just want to hit on this because I think it's so important. What you said is, in so many cases, the taxpayers have invested millions, if not billions of dollars on developing this technology in our national labs. But what's that return on investment? How is that technology being deployed to meet or address the issue that it was initially developed for? And I think that that's such an important point. And frankly, that's exactly why I think our office was created. And so I'm curious, 2 points, or 2 questions. What drew you to start working at a lab, one of our national labs? And then 2, your lab is phenomenal, by the way, but specifically Sandia National Lab has done a really good job of kind of taking out that leap of faith in going to commercialized technology. So it allows them to leave their lab, attempt to commercialize that technology. Should they fail, which you appropriately acknowledge sometimes and often happens, they can come right back to the lab. Their position is safe. And so now all of a sudden that leap of faith is a little bit less scary. So I guess two questions. One, what drew you to come start working for one of our amazing national labs? And then two, what could we as Department of headquarters for the Department of Energy, specifically my office as the Chief Commercialization Officer, how could we make it easier for people to be more like you, frankly?
Well, so first, I was originally hired as a professor at UC Berkeley. And UC Berkeley is attached at the hip, literally, side by side with Lawrence Berkeley National Laboratory. And so I got a faculty scientist position at Lawrence Berkeley National Laboratory shortly after I got to UC Berkeley. And what was so clear to me is that while a university is great for individual laboratories and for teaching students science and technology and engineering, national labs are where you can do things with lots of people. And you can do really big, really difficult projects. And you can put a lot of resources together that's been maybe built up over decades at the national lab to solve some new problem. And so I kind of became addicted to this team science that you see in national laboratories. And this is exactly the science that needs to go on in a company, is team science. And I think often we don't see that in universities, and it's difficult to teach because everybody's got to get a PhD, or every undergraduate's got to have their thesis. And those, I think, in the past have been thought about as individual siloed kind of things that they have to do on their own. But I think we're moving into this area, and a lot of it's taught by our Department of Energy national laboratories about working together in teams, still having your individual piece of it, but be a piece of a larger puzzle. And so I think this is really great to train future entrepreneurs. I think it's super important for the national labs to be flexible with employees, allowing them to go into companies and start those companies and to come back if they need to. Many of these entrepreneurs, once they catch the bug, I started out calling this a disease, but it's once they catch that bug of being an entrepreneur, then they're going to do it over and over again. And, so I founded quite a few companies myself, but the students from my laboratory have funded a bunch of other companies, either on laboratory intellectual property or things that they've created after the fact. And then those entrepreneurs go out and, once they've completed one company or they've had a failure, they'll start another one. And so you get this ecosystem of people that are really interested in getting things out to people and making a difference in the world. And so I think the national labs have, in the past, played a big role and can play an even bigger role.
I couldn't agree more. I think our national labs really are one of the greatest resources that we have in this country. But so many times, the people in the lab just want to do peer-reviewed paper after peer-reviewed paper, and they don't necessarily aren't focused on trying to commercialize it, which is why everything you've done and continue to do is so amazing. I'm curious, going back to your earlier in your career, what attracted you to synthetic biology and redesigning the PKS process?
Yeah, so when I was a kid, I remember it was either Time Magazine or Newsweek or something. This will date me a bit, but this was in the 70s, reading about the founding of Genentech and how they had, thousands of resumes come in for these jobs. And it was this idea that you could engineer biology to produce, in their case, critical medicines. And we were no longer extracting cadavers for human growth hormone or getting insulin from pigs. We were actually going to produce it using engineered microorganisms. And I just thought that was the coolest thing ever. And I had to be part of that. I grew up on a farm, and so there weren't a lot of examples of scientists on the farm, although we had science every day on the farm with the engineered crops that started when I was a kid, and unfortunately all the pesticides and fertilizers that we also had to put on the crops. But it was just this idea that you could engineer biology to solve some critical problems. And I fell in love with it then, and just kept working on it. And it's amazing the technologies that we have available. When I started at Berkeley as an assistant professor in 1992, we didn't have the World Wide Web. We had no sequenced organisms, not even a bacterium. And because of the technology developed in the DOE National Labs for the Human Genome Project, we're sequencing, hundreds of these organisms a day. And the power we have to engineer biology is tremendous. And so I think it's just the tip of the iceberg of what we can do.
The technology you developed, I have to admit, to a non-scientist like me, are truly mind-boggling. And as a commercialization guy, I see their truly incredible potential. And I'm interested in knowing how and why you chose to steer your research into these particular areas. Did you think about the possibility of commercialization first before choosing what to pursue, or were your natural interest and intuition just serendipitously from a commercialization standpoint?
That's a great question. I approach it from both the science and doing new science side, but also with some use in mind. I call it use-inspired basic research. And they have to play off each other, right? There's this book about Pasteur's quadrant, right, where you don't necessarily want the Edisonian approach, but you want that kind of perfect mix of a need, but also some basic science that's going to go into it. I was, as an undergraduate, I was trained as a chemist. Now, I'm not a good chemist at all, but what I realized is that biology can do tremendous chemistry, and even some sophisticated chemistry that synthetic organic chemists have a difficult time doing. And so being able to engineer biology to do this chemistry and produce a life-saving therapeutic, or produce a biofuel, or produce a new material that will replace plastics but yet can be recyclable, those could have potential impacts on all of our lives and on the environment, and improve the planet, and give new properties. Yeah. So there's a lot that you can get out of this, as well as doing some really deep science. And since biology there's so much unknown in biology, we have to do a ton of science just to get to the application. And I think that's really fun and interesting. And I'll say that the Department of Energy, through the Office of Science, has been a fantastic supporter. Also through EERE, I've gotten tremendous support for both of them, especially in putting this chemistry inside cells, first to produce biofuels and now to produce new materials.
Well, you kind of hit on this, but there really has been a lot of progress in synthetic biology and chemistry since you've entered the field. I'm curious what some of the breakthroughs and advancements that we're seeing right now, what excite you?
Well, I mean, you can't open up or I can't open up my email and not hear about AI and ML, right? And it's just in every part of our lives now, and it's affecting biology and biological engineering in a huge way. I mean, the Nobel Prize this past year was given for protein structure and protein design, and it's tremendous what we can do. The national labs have these cyclotrons that have been amazing for getting protein structures, and we have databases of these, and so they basically used AI on all of these structures to then be able to use now an application, a computer application, to find the structures of unknown proteins. And it is incredibly powerful when we want to go in and engineer those enzymes to do new chemistry inside the cell. And we use this on a daily basis, and it's progressing so fast you can't keep up with the literature. It's really wonderful, and we're going to come to the point where we're going to be able to design cells de novo. And there's some scary sides of this as well, but it's tremendously powerful.
Yeah, I will agree with you. I hear about AI about 100 times a day. And it really is amazing. I just kind of, from a personal perspective, a lot of what we're talking about right now is, synthetic biology and all this other kind of stuff. But it's amazing what's happening in our national labs. It really is. And I think sometimes people think, oh, well, you work at the Department of Energy, you work with the labs, so you're just dealing with energy. It's like so much more than that. It's really, whether it be quantum or synthetic biology or fusion or nuclear weapons, all these amazing things are happening in the labs, and truly every sector of the economy is being advanced in our national lab complex. And so I'm curious, could you talk about, you've mentored researchers and entrepreneurs at both Berkeley Lab and the Joint Bioenergy Institute. What are, talk to me about that.
Yeah, so the Joint Bioenergy Institute is one of the bioenergy research centers that were first developed in 2007 in the George W. Bush administration. And they came about in part because the U.S. was importing 2/3 of its petroleum, and the price spiked, and so they wanted an alternative to this. At $125 a barrel, $150 a barrel, biofuels can kind of compete, but at the prices that they hover at, most of the time, it's very difficult for them to compete without, some type of subsidy or requirement. But it's the basic science that goes into developing those organisms that are going to produce biofuels from sugars and from plant waste or from plastic waste or something like that. And there's just so much basic science in that. And in terms of training, the students and postdocs who come in to work in this field can then go out and get jobs in any number of industries or start companies that will, be biofuels companies or companies that will make chemicals that'll be replacements for the petroleum-derived ones or make better chemicals than what you can get from petroleum. So I think the students come into this in part because they're interested in helping the environment, they're interested in the technology, they're interested in engineering biology, but they may not leave doing that. But we've served them very well, and we've served the country very well by training them in this, cutting-edge area of science and technology.
What larger impacts do you hope your research and the many startups you've been involved with founding will have?
For me, I often say, when we're working on pharma projects, that I want to see that molecule made from our engineered organism in the veins of people. And or I want to see a material that's being used This anti-malarial drug, it's been in the veins of children in Africa and saved lives. That same company that helped us work on that has I think it's 13 different molecules in consumer products right now. If you used an emollient skin cream, you might have gotten that molecule, which is called squalene, that would normally be gotten from sharks' livers, but they've engineered yeast to produce it, and you can produce it in pure form. Those are the kinds of great things where you can see somebody benefiting from the work you did. Now, I said I've had a lot of failures, and most of the time, these kinds of things don't happen, right? But training people is probably even more important because you never know when you're going to come up with the next Pasteur or Einstein or whoever it is, and those people are going to go out, or Steve Jobs, or somebody like that who's going to go out and found a company. And so I think creating an environment for graduate students and postdocs where they can fail, they can try something really risky and know that they won't be punished for failing. That we can celebrate failure, and it's not a failure as long as they learn, and maybe the next time or the next time after that it won't be a failure. And I think this is something that's really unique in the U.S., and maybe we have it in spades in the Bay Area, but just this idea that failure is not a bad thing, and that as long as you learn from it, it's not a failure, and just get on with the next thing.
That's great. What do you hope the next generation of researchers, scientists, and innovators will bring into the space? And do you have a vision for the next 5 to 10 years in synthetic biology and chemistry field and at large, and what challenges do you see ahead?
Well, as I mentioned, with the AI and ML and enzyme design, protein design, there's going to be so much innovation that's going to come from that. And it's going to be really exciting to see where this goes. And I'm looking for replacements of all kinds of chemistry with biology. And it's not just to replace it, it's to do things in an environmentally friendly way. I'm from a farm in Nebraska, as I mentioned, and I'm also addicted to this idea of taking agriculture products, agriculture waste, and making more of them. A lot of the corn that we used to raise on my farm went to producing ethanol. That's important. It's an important oxygenate in gasoline, and widely used, but we can do more. And the Department of Energy Research is getting us there. So I'm looking to see us, expand and do even more in this space. I'm looking for more and more entrepreneurs to go out there and start new companies. Right now, it's a bit of a rough time in industrial biotech. There's been quite a few companies that have failed, and that's okay. That's okay. You start to spook investors when things like that happen, and so I'm a little bit concerned about that. And so I've been telling people, you know what? Take technical risk. Take lots of technical risk. But don't take a huge amount of money. Take what you need and spend it very conservatively. I think the government, through the SBIR programs, plays a really important role, especially in times where the investment community now is a little bit weary. don't know where things are going with the economy, and so they're not investing the way they were. I would say there was a point where they were investing too foolishly, maybe, putting too much money in things. Now it's a little difficult, but I think this is a perfect time for the government to step in and having a really robust SBIR program. I'd argue that we could increase the amount that is awarded, but I think that's really important.
Well, little teaser for you. I think that we are going to work to change a lot of the ways that SBIR, STTRs are done at DOE, and I think as we are going through reauthorization, there's at least a consideration for DOE to be able to award a higher award numbers similar to DOD. Mm-hmm. And so those strategic awards, I think that they're called. So I think there's a lot of opportunity for improvement for the SBIRs, STTRs, especially at DOE. And I'm looking forward to helping support that effort. Hopefully I won't regret this question, but it's okay if I do. How could I help as the Chief Commercialization Officer? How could I support more entrepreneurial spirit and the willingness to be more entrepreneurial within the labs? And how can I help reduce that leap of faith and whatnot? I mean, how can I support innovators within the lab better?
So I think the national labs have come a long way. They have these programs. I think it was launched at Berkeley Lab, in fact, Activate. I think that's great. I think having even more of that put that on steroids, because I think those kinds of programs, it's super competitive to get into those programs. I've had a couple of former graduate students get into those programs. It's super competitive. It's really getting some of the best people and ideas out there. I think we need to do more of that. I think if we give out more SBIRs, encouraging undergraduates too through startup competitions and things like that, I think is really great. The NSF I-Corps program, and DOE has taken this up, is super important because, I can teach science and technology development, but I can't teach I can't tell people what companies want. Mm. It's hard to get that out of companies, and I think these kinds of programs are really important because, as I said, the technology, the science often works. It's the business side that doesn't work, and we've got to get more in there. So just keep doing those kinds of things. I think, encouraging people through various mechanisms, I think it's super important.
Well, I'm grateful for you, for all the work you've done over the last few decades, and for not only starting these companies, but the amazing success you've had in not only doing founding these companies, co-founding these companies, but also the amount of money you've been able to acquire in the private sector. And I'm just grateful for you to come up on stage here with me and share your words of wisdom. And so if everyone would join me in congratulating Jay for his amazing accomplishments. Thank you.